standard practice in the oil industry, at least since the 1930s. For mineral exploration, the method is getting more common as targets get more complex and exploration more expensive. Downhole logging can provide a large amount of data that can contribute to all aspects of an exploration project, as we will show in this video. Kenix has used downhole logging since 2015 to help advance our own and our clients' projects. Drilling and sampling provide a compromise between expediency and data collected. Diamond drilling can provide more detail as well as structural data. RC drilling, on the other hand, can provide well-mixed samples, fast and at a much lower cost. By collecting downhole data, you can achieve with RC drilling what is normally only possible for diamond drilling and get additional millimetre to centimetre scale physical property data as well. Downhole data is collected after drilling as an added workflow to a drilling program. The holes are left open for the wireline field technicians, who can log about 5 holes per day. In addition to physical property and televiewer data, downhole logging also supplies hole orientation data and precise depth measurements. This will especially add value to RC and similar drilling, but also complements diamond drilling. The optical televiewer is a 360 degrees RGB line scanner that works with orientation sensors to generate a millimetre scale image of the drill hole wall. This image can be used for lithological and structural interpretation. Downhole physical property logging is similar to what can be measured on samples and on core. However, you get a continuous record down the hole. Density is measured at centimetre scale as backscatter from an active gamma ray source. The data provides important information about lithology, alteration and mineralisation. Here, compared to logged RC samples, the relationship between lithology and density is very clear. Natural gamma radiation is measured as background radiation from the rocks themselves. Felsic rocks and clays have high contents of radiogenic elements and will be picked up by this tool at centimetre scale. Magnetic susceptibility measures the deformation of a magnetic field extended into the drill hole walls. This finds iron oxide minerals, especially ferromagnetic minerals such as magnetite. Statistics on the physical properties can be used to generate a set of classes that can relate to lithology and in the process improve the geological resolution to centimetre scale. Optical and acoustical televiewers can add a lot of detail to lithological logging. Features lost to RC drilling, for example, will still show up in the drill hole wall images, and the images can provide a virtual drill core. Here is an example where an interval of granite appears to contain dispersed gold. However, the televiewer image shows a vein that may be a more localized source of the gold. One of the main strengths of televiewer images is the ability to gain oriented data on linear elements such as veins and foliation. The images are shown unwrapped. Features logged are converted to oriented planes by the software. Fractures, veins, contacts and foliation can be logged to any level of detail. Downhole data, when combined with all other exploration data, will greatly help with understanding and mapping the geology of your project in 3D. A common issue when interpreting 3D geology from RC logging is the apparent dip trap. The orientation of drill sections can steer the interpretation of rock boundary orientations. Televiewer image interpretation can overcome this by allowing orientation data to be captured and by adding detail to the sample logging. In this example, we show how conventional correlation between holes can be guided by structural data gained from the televiewer images. The result is radically different from the outcome without the orientation data. The granite sheet now cuts a package of gneiss with a very different orientation. Using physical property data also allows for further differentiation within units that would normally be lumped together by visual logging. For example, downhole density data collected during resource drilling can greatly improve the accuracy of resource models. Here the blue unit is characterised by relatively higher density and occasionally of higher natural gamma radiation. When related to the occurrence of mineralisation seen in RC samples, constraining this unit helps domain 3D models and reduce the prospective rock volume for better resource definition. Okay, so what are the benefits of using wireline logging? By adding downhole logging to your drill program, you can get maximum data at minimum extra cost. It allows you to better understand the physical rock properties, lithology and structure of your project. It allows you to take a significant step to accurately constraining the geology of your project in 3D. And importantly, you can use this data to build robust geological interpretations, improve resource estimation with accurate density and structural models, and target that mineralisation in 3D. If you're interested and would like some more information, contact Andrew at kenex.com.au or visit our website www.kenex.com.au.